Now you can give your attendance in the chat box. I repeat, those who have joined the class can give his or her attendance in the chat box. We'll
Good
start
afternoon.
by 3:06 p.m. I will wait for 3 more minutes. Okay, it's around 3:06 p.m. So let us start the class. Let me present my screen first. Can anyone confirm me whether you can see my slides or not?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, fine. Okay, let me give you a brief of what we did in the last class. In the last class, we solved few previous year's GATE problems on different theories of failures. We solved some 3 to 4 problems we solved. Then we started our discussion with design against fluctuating or variable load. I told that fluctuating or variable load in any machine component will give rise to fatigue failure. After that, we also discussed about the different types of mathematical models available for cyclic stresses. Those are fluctuating stresses, repeated stress, and reversed stress. These are the stress versus time diagram for fluctuating stress. This is for reversed stress, and this one is for the second one is for repeated stress, and the third one is for reversed stress. From these diagrams, we came to know that sigma m, that is mean stress, is given by sigma m, that is mean stress, is given by half times of maximum stress plus minimum stress, and alternating stress sigma a is given by half times of maximum stress minus minimum stress. We also defined one ratio called stress ratio, which is given by capital R is equal to sigma mean divided by sigma max, and amplitude ratio, which is given by sigma a by sigma m. I think in the till the last class we have discussed till this topic. If anyone can confirm me.
Yes, sir. इन तक हो गया था.
यहाँ तक हुआ था, right? Okay, okay, okay. So let us move forward. Let us move forward. Fine. Next topic is my fatigue and endurance limit. What is a fatigue and endurance limit? Likewise, in UTM, if I am having a ductile material or if I am having a brittle material, if I test that material in UTM, then ductile material fails due to yielding phenomena and brittle material fails due to at ultimate tensile strength point. And I got two graphs of stress versus strain diagram for ductile material and one for brittle material. In similar manner, if I am having a component, if that component is subjected to fluctuating stresses, that means if on a component fluctuating load acts or cyclic load acts, then that component will be subjected to fluctuating stresses or fluctuating load. If I test that component in a rotating beam fatigue testing machine, then I will come to, then after some time period I come to know that machine component is failed in fatigue. The point where the failure takes place, that means the point where the fatigue failure takes place, that point is known as fatigue limit or endurance limit of the material. Likewise, if I take a ductile material, I know that plastic deformation in ductile material takes place after yield point. Similarly, in fatigue, the material where the material will fail just after the fatigue limit or the endurance limit point. In ductile material we draw stress versus strain diagram, but in this but when the component is subjected to cyclic stresses or fluctuating stresses, then we plot one diagram. That diagram is versus strength versus number of cycles diagram, and that diagram is known as SN diagram. And that diagram normally looks somewhat like this. This line is somewhat a straight line, and from this at this point the line becomes almost horizontal. Fine. The point from where the line becomes almost horizontal, that point is your failure point. That means this particular point along y-axis, that means this length is nothing but my endurance limit value, and we denote endurance limit by SE. And this x-axis is nothing but number of cycles. But keep in mind, this stress strain diagram is drawn on a log paper. That means this x-axis is log base 10n and this y-axis is log base 10 sf. This you have to keep in mind, that this diagram, we draw this diagram on a log paper. X-axis represent number of cycles, y-axis represents strength. Which strength? Fatigue strength. That means x-axis will be log base 10 n, n is number of cycles, and y-axis will be log base 10 sf. Is it clear? Fatigue limit and endurance limit.
हाँ सर, क्लियर है.
बाकी लोग को कोई डाउट इसमें?
No, sir, no, sir.
ओके ओके. कभी कभी गेट में क्या करता है कि दे विल गिव यू दिस डायग्राम, चार डायग्राम बना के दे देगा, एंड दे विल आस्क यू दैट व्हिच वन इज द करेक्ट डायग्राम ऑफ एस एन व्हिच वन इज द व्हिच ऑप्शन इज बेस्ट मैचेस विद द एस एन डायग्राम. तो अगर आपको डायग्राम पता है आप तुरंत टिक कर लोगे. Fine. Okay. Next is calculation of factor of safety for fatigue loading. We know that factor of safety is what? Factor of safety is nothing but equal to allowable failure stress divided by allowable stress. Fine. So allowable stress will be equal to failure stress by then your allowable stress will be equal to failure stress divided by factor of safety. Can you tell me in fatigue loading what is your failure stress? In fatigue loading, what is my failure stress?
Endurance limit failure. Endurance limit.
Yes.
AC,
In
AC.
fatigue, whenever the body is subjected to fatigue, the failure stress is nothing but the endurance limit stress. Failure stress is nothing but the endurance limit stress. Keep in mind, if the material is failing in yielding, then that failure stress will be the yield point stress. So here the formula becomes, if for normal loading, allowable stress is equal to failure stress, that is fatigue limit stress, that is nothing but endurance limit stress AC by factor of safety. If the same material is undergoing fatigue in terms of shear, then that formula becomes allowable shear stress tau is equal to fatigue strength in shear. Failure stress becomes fatigue strength in shear, SSE by factor of safety. क्लियर है ये दो फॉर्मूला? कब यूज करना है? कोई डाउट किसी को?
No, sir.
ओके 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 फाइन. नेक्स्ट, दिस इज स्पेसिफिकली एस एन डायग्राम फॉर स्टील्स. कभी कभी ऐसा भी होता है कि डायरेक्टली पूछता है कि स्टील के लिए कौन सा ऑप्शन बेस्ट सुटेबल है फॉर एस एन डायग्राम. फाइन. So for SN diagram for steel, generally this is a straight line. This is an inclined straight line, and from this point, when this line becomes exactly parallel to this x-axis line, that is your number of cycles line, this particular point is your endurance limit point. But if you see this diagram is when you test any specimen in rotating beam machine, then this line will not be a straight line, it will be a near about a kind of straight line, but it will not be a straight line. But if you consider especially for steel, definitely this line be a straight line. So there is a difference between this diagram and between this diagram. This is the SN diagram specifically for steel, and this is the SN diagram for any material or any component which you are undergoing fatigue in rotating beam fatigue testing machine. तो दोनों को आप ध्यान में रखोगे, ये डायग्राम कब एप्लीकेबल है और ये डायग्राम कब एप्लीकेबल है. क्लियर है? कोई डाउट किसी को?
नहीं सर.
No, sir.
Okay, fine. And these points
स्टील
are
के लिए
called
पूछेगा तो ये
failures.
डायग्राम देखना पड़ेगा.
क्या बोल रहे हो?
स्टील के लिए ये एसएन डायग्राम है ना, अभी जो आप दिखा रहे हैं.
This, yes, the whatever slide I am showing you right now, this is SN diagram specifically for steel. For steel, normally you get a straight line like this, and then you get a straight line parallel to your x-axis. The point where you get the line parallel to x-axis, that particular point along this y-axis is your endurance limit stress value. But normally when you test any material in rotating beam fatigue testing machine, that line does not looks like a straight line. वो स्ट्रेट लाइन नहीं होता है, ऑलमोस्ट स्ट्रेट लाइन के आसपास हो, लेकिन स्ट्रेट लाइन होता नहीं है. इसलिए देखो यहाँ पे हल्का सा कर्व बनाया है मैंने यहाँ पे. फाइन. तो दोनों डायग्राम दोनों अलग अलग स्पेसिफिक पर्पस के लिए यूज होता है, तो ये आपको पता होना चाहिए. दोनों डायग्राम ही ऑप्शन में देगा, ऑप्शन में दोनों डायग्राम देगा और बोलेगा कि फॉर स्टील विच डायग्राम इज करेक्ट, तो आपको ये वाला ऑप्शन मार्क करना है. फॉर एनी मटेरियल विच डायग्राम इज करेक्ट, देन आपको ये वाला ऑप्शन मार्क करना है.
क्लियर है सर.
देख रहे हो दोनों में डिफरेंस? डायग्राम ऑलमोस्ट सेम है, बट दोनों का एप्लीकेशन थोड़ा अलग अलग है. फाइन. एंड दिस डायग्राम इज ऑल्सो नोन एज होलर डायग्राम, WHOLER. इस नाम से भी पूछा जा सकता है गेट में. होलर डायग्राम. दो नाम है इसके. वन नेम यू कैन कॉल इट एज एसेंड डायग्राम. सेकेंड नेम you can call it as Euler diagram. Okay, next. Next is again, this is one important question they can ask you in GATE. What is low cycle and what is high cycle fatigue? अगर आप देखो इस डायग्राम को, ठीक है, जो एक्स एक्सिस है, एक्स एक्सिस कहां से चालू हो रहा है? 10⁻³ साइकिल से. फाइन. सिमिलरली अगर आप यहां पे देखो, ये जो मैंने डायग्राम बनाया है कहां से चालू हो रहा है? 10⁻³ साइकिल से. बट नॉर्मली कोई भी ग्राफ चालू होता है ओरिजिन से, ओरिजिन पॉइंट, origin 0 of x, origin 0 of y. Similarly, this ascent diagram also starts from origin. This is origin 0 for x, origin 0 from y. So from origin to 10⁻³ cycle, if the failure is occurring, fine. So from the origin point till 10⁻³ cycle, if the failure is occurring, that failure we call it as low cycle fatigue failure for any particular material. And from 10⁻³ cycles to the final limit, that limit we don't know, because this curve becomes straight parallel to x-axis for infinite life. So from 10⁻³ cycles to infinite life, if you classify this curve, you have to call this curve as high cycle fatigue. Difference between low cycle fatigue and high cycle fatigue. Low cycle fatigue you will get up till 10⁻³ cycles in SN diagram, and high cycle fatigue you will get from 10⁻³ cycles till the last point. And that last point will depend from material to material. That is your high cycle fatigue. Is it clear difference between low cycle fatigue and high cycle fatigue? Any doubt?
Yes, sir. Yes, sir.
Okay, fine. Okay, if you can see the chat box, DKD sir has given link of attendance link. Please fill up that attendance form link. Fine. Okay, let me continue my class. Fine. But remember one thing, there is a change. There is a change. See, this line, where it will meet, this line will meet on y-axis at this point. That means at the ultimate strength point. That means this value will be along y-axis. If you measure from 0 to this much length, this length will be log base 10 of SUT. This is your endurance limit stress log base 10 of SE. If you talk about this point, this is log base 10 of 6. 10⁻⁶. This is 1, 2, 3, 4, 5, 6 is what? This is 10 to the power 1, 10 to the power 2, 10 to the power 3, and so on. If you solve in the problem log base 10, 6, your problem will be wrong. ये 10 to the power में है. ये 6, 5, 4, 3, 2, 1 ये सब 10 to the power में है. Clear है? कोई डाउट किसी को?
क्लियर है क्लियर है
लो साइकिल एंड हाई साइकिल फटीग, बाकी लोगों को कोई डाउट किसी को?
No, sir. No, sir.
ओके फाइन. आगे बढ़ते हैं. नेक्स्ट इज स्ट्रेस कॉन्सेंट्रेशन. व्हाट इज स्ट्रेस कॉन्सेंट्रेशन? आप ही लोग बोलो, क्या है स्ट्रेस कॉन्सेंट्रेशन? याद करो, बताया था मैंने लास्ट क्लास में. मैंने
Sir, if there are any. Hello.
हाँ, जब लास्ट टाइम मैंने पढ़ाया था, मैंने आपको एक एग्जांपल दिया था. मैंने एक पेपर लिया था. पेपर को मैं क्या कर रहा था, मैं दोनों तरफ से आई वाज ट्राइंग टू टीयर द पेपर, बट आई वाज नॉट एबल टू टीयर द पेपर. बट मैंने क्या किया सेकेंड टाइम, मैंने बीच में एक सेंटर होल कर दिया पेपर में, एंड देन आई ट्राइड टू टीयर द पेपर फ्रॉम द बोथ एंड्स. पेपर इजीली गॉट ब्रोकन इनटू टू पार्ट्स. तो उससे क्या समझ में आया, क्या है स्ट्रेस कॉन्सेंट्रेशन?
Sir, if there are any irregularities in the surface, then we can easily break it. So means
Yes,
stress
yes, yes.
concentration is more for that case.
Yes, yes, that means wait, let me give you wait.
पेपर वाला एग्जांपल सर दिए थे वो याद है
हाँ पेपर वाला एग्जांपल दिया था वेट आई विल शो यू बाय अगेन ओके can you see my screen now, this white screen?
यस सर
Hello.
Yes,
Okay,
sir.
okay.
यस
Yes,
That
sir.
means if this is my paper, fine. Earlier, what I was doing, I was applying stress along this end, and I was applying equal and opposite stress along this end of the paper also. But I was not able to tear the paper into two parts. But second time, what I did, I put a hole over here. Why I have given a hole over here? But now the strength of the paper is reduced due to application or due to insertion of this hole. That means stress will be maximum along this whole region and minimum along the other region. Now, if you try to now pull this paper, your paper will get tear into two parts, somewhat like this. This is the first part, and this is the second part. Yes or no?
Yes,
Hello.
sir.
And if you see where means the place where the irregularity is more, that means exactly at the center point, it is maximum stress point. It is maximum stress point as compared to other point in the material. So this is nothing but the concept of stress concentration. Fine. That means if you want to break your material quickly, you insert notches in your specimen. That notch can be a hole, that can be a V notch, that can be a U notch, depend. Fine. So that is my stress concentration. If I define, it will be stress concentration is what? It is nothing but the localization of high stresses due to irregularities present in the component and abrupt change in the cross section. See, here cross section is changing. See, at this part cross section is changing. At this part cross section is changing. Clear? कोई डाउट है किसी को यहाँ पे स्ट्रेस कॉन्सेंट्रेशन में?
हाँ सर क्लियर है मतलब जितना ज्यादा इरेगुलेटरी होगा स्ट्रेस कंसंट्रेशन बहुत ज्यादा होगा
Yes. So there is a term while solving problem. There is a term in stress concentration, and that term is known as stress concentration factor, denoted by symbol Kt. What is this? This is nothing but the ratio of maximum stress divided by nominal stress. And what is this nominal stress? This nominal stress, you find it out for different problem. For example, if in a problem bending is happening, then this nominal stress will become the bending stress. How you will find out? M into I by I. If in some problem tension is happening, this normal stress will become sigma is equal to P by A. If in some problem torsion is happening, this normal stress sigma naught will become T by J, tau by R, G theta by L. You have to use that expression to find out the value of this tau. And sigma max will be given to you in the problem. So with that, you can calculate the value of Kt. Kt is equal to sigma max by sigma naught. If normal stress is acting, if shear stress is acting, it will be tau max by tau naught. Is it clear?
Yes, sir.
Okay. For example,
यस
let us take this example. In this example, can you tell me where is the change in cross section, or at which point? If I want to design this problem, which point is critical in this diagram? This first diagram.
Sir, AB.
Why that point is critical? Because at that point I have created a fillet. At that point, cross section has been changed. So material will fail due to this load. Firstly, at that point, that AB cross section point region. Clear? Hello.
Yes, sir.
Okay,
हाँ
okay,
सर क्लियर है.
okay. Fine. So for this, since this is a problem of tension, so maximum stress will be how much? Maximum stress will be kT times of sigma nominal. And I told that sigma nominal will vary from problem to problem. In this problem, tension is happening, so it is P by cross-sectional area A. You will get the value of sigma max. Sometimes see here, if you see the cross section of the hole is circular, it may also happen that in a plate cross section of the hole is elliptical in nature. ऐसा भी तो हो सकता है कि क्रॉस सेक्शन ये जो आपका जो स्ट्रेस कॉन्सेंट्रेशन है फाइन, वो आपका इलिप्टिकल नेचर का हो, तो व्हेन इट इज ऑफ इलिप्टिकल नेचर, हाउ टू फाइंड इट आउट द वैल्यू ऑफ केटी, बिकॉज दिस यू हैवंट स्टडीड इन योर बीटेक, बट ये गेट में आता है यहाँ से क्वेश्चन, क्योंकि बहुत लोग ये पढ़ते नहीं है गेट में, इसको इसको छोड़ के जाते हैं, यहाँ से आ जाता है फिर क्वेश्चन होता नहीं है. फाइन. So when the shape is not circular, when it is elliptical in nature, then I know that in ellipse there are two axes. This is called major axis, which is nothing but 2a. This is called minor axis, which is nothing but 2b. Then the stress concentration factor, I will not use this formula to calculate the value of stress concentration factor. In such case, stress concentration factor is given by the formula Kt is equal to 1 plus 2a by b. 1 plus 2a by b. For circular hole, a and b is same. A and b is same, and Kt is equal to 2 plus 1, which is equal to 3. But if the hole is elliptical in nature, then you have to use this formula. A and b will be given to you in the problem. कोई डाउट इसमें यहाँ तक?
नहीं सर.
No,
ओके.
sir.
बाकी लोगों को कोई डाउट? कृषाणु कोई डाउट? हेलो. Okay, okay, let us move forward. Next is notch sensitivity. What is notch sensitivity? Before understanding what is notch sensitivity, let us find it out. What is KF? This is also important for solving problems. KF is my fatigue stress concentration factor. It is defined as the ratio of endurance limit of notch free specimen divided by endurance limit of notch specimen. That means you are having two specimen. In one specimen they are of same shape, size, everything is identical. In the first specimen there is no notch. What is the value of endurance limit? Divided by, in the second specimen you have made a one smaller notch. That notch can be anything. That can be in the form of circle, ellipse, V shape notch, anything. Then for that particular member, you will find out what is the endurance limit. If you take the ratio, you will get the value of Kf, that is fatigue stress concentration factor. But this formula is applicable for experimental purpose. But mathematically, I use this formula of Kf as Kd is equal to 1 by Kf. I will tell you later on what is this thing. Fine. Yes, this formula Kf is equal to 1 plus Q times of Kt minus 1. What is Kf? Kf is your fatigue stress concentration factor. What is Q? Q is your this notch sensitivity factor. And what is this Kt? Kt is stress concentration factor. How I will define this notch sensitivity factor? It is nothing but the ratio of increase of actual stress over nominal stress divided by increase of theoretical stress over nominal stress. Increase of actual stress over nominal stress is how much? Kf into sigma naught minus sigma naught divided by increase of theoretical stress over nominal stress is Kt sigma naught minus sigma naught. If you solve that expression, you will get this value of Kf. Ultimately, you have to remember this expression of Kf. Kf is equal to 1 plus Q times of Kt minus 1. And I think in 2018 or 17, I don't recall, this formula they have asked. इस फॉर्मूले से उसने Q का फॉर्मूला पूछा था कि Q क्या होगा. Q क्या होगा? Q इज इक्वल टू Kf माइनस वन डिवाइडेड बाई Kt माइनस वन. अगर आप देखोगे प्रीवियस ईयर्स के का गेट का पेपर में, ये आई थिंक 2017, 18, 19 में से किसी एक साल आया था कि Q क्या होगा. Q is equal to Kf minus 1 divided by Kt minus 1. So this formula is important. But remember one thing, when to use this formula? You will be using this formula if the material is having no sensitivity to notches. That means नो सेंसिटिविटी टू नॉचेस मींस नॉच प्रेजेंट ही नहीं है मटेरियल में. अगर नॉच प्रेजेंट ही नहीं होगा तो केटी होगा ही नहीं. केटी नहीं होगा तो क्यू भी नहीं होगा. दैट मींस क्यू इज इक्वल टू जीरो. इफ क्यू इज जीरो, जीरो इंटू केटी माइनस वन, दिस एंटायर थिंग इज जीरो. सो के एफ इज इक्वल टू वन. And when the material is fully sensitive to notches, that means if in a material notch is there, then definitely Q will be there and KT will be there. In that case, Q is equal to 1. Substitute the value of Q equal to 1 in this expression. If Q is equal to 1, so this expression becomes Kf is equal to 1 plus Kt minus 1. Plus 1 minus 1 cancel. Kf is equal to Kt. So you should remember this formula. Then how Kf is equal to 1 from this formula, how Kf is equal to Kt from this formula, this also you should remember for gate. And that is the thing. So is it clear?
Yes, sir.
बाकी लोग के लिए कोई डाउट है किसी को कुछ? बाकी किसी को कोई डाउट है? Okay, I don't think he कोई respond नहीं कर रहा है. That means I don't think there is any doubt. Okay, let us move forward. Next is estimation of endurance limit. This endurance limit, whatever we have got from SN diagram, that means this limit. Mathematically, how I can find it out? This is experimental calculation, but mathematically, if I want to find out, that is given by the relationship, this one. By the relationship AC is equal to KA, KB, KC, KD, SE dash. AC is equal to KA into KB into KC into KD into SE dash. अगर आपको याद होगा तो मैंने मैंने कराया था ये फॉर्मूला, याद है किसी को?
Yes, sir. Yes, sir.
AC is equal to KA, KB, KC, KD, SE dash. अब
हाँ
इसमें
सर, हाँ सर,
हाँ सर याद है.
अब इसमें एक प्रॉब्लम है. प्रॉब्लम क्या है कि दिस AC एंड दिस AC डैश आर टू डिफरेंट थिंग्स. ये याद होना चाहिए. फॉर्मूला तो आपने याद कर लिया, बट आपको पता होना चाहिए कि AC क्या है, AC डैश क्या है. तो अगर आपको दो वैल्यू दे दिया है 125, अब ये 125 AC है कि AC डैश है, कैसे पता चलेगा? उसके लिए you have to remember this thing. That is AC dash is what? AC dash is the endurance limit stress of a rotating beam specimen subjected to reversed bending stress. That means when you test any particular component, that component in rotating beam fatigue testing machine, to find out the value of endurance limit, to find out this SN diagram, that is that AC dash. जब आप रोटेटिंग बीम फटीग टेस्टिंग मशीन को टेस्ट करते हो, किस पे टेस्ट करते हो? रोटेटिंग बीम मशीन में जब आप टेस्ट करते हो, जब वो कुछ टाइम के बाद फटीग होता है, तो जब फटीग हुआ उस समय जो एंड्योरेंस स्ट्रेंथ प्रेजेंट था बॉडी का, दैट इज एसई डैश. That means this AC dash. और जो mathematical AC that we calculate for each and every material, that is endurance limit stress for any particular mechanical component subjected to reverse bending stress, that we calculate by multiplying this original AC dash from that fatigue testing machine with multiplication of some factors, that is Ka, Kb, Kc and Kd. Ka is surface finish factor, Kb is size factor, Kc is reliability factor and Kd is modifying factor. And this modifying factor also, I know that it is nothing but 1 divided by Kf. Kf is this expression and Kd is 1 divided by Kf. So if I know the value of Kf, If I know the value of Kf, I can easily calculate the value of Kd. Ka, Kb, Kc, some data will be given to you in the problem. डेटा बुक तो देगा नहीं गेट में, तो इससे रिलेटेड कुछ डेटा दे देगा कि Ka, Kb, Kc कितने कितने बीच में वेरी कर रहा है. Then you can easily calculate this formula of AC. AC is equal to Ka, Kb, Kc, Kd, Se dash. Fine, but also remember one thing, these things can be given in the gate problem, may not be given, I am not sure. But if not given, you can memorize these things. That is, for steel, this AC dash value is given by 0.5 times of SUT. For cast iron, that same AC dash value is zero point 0.4 times of SUT. For wrought aluminium alloys, AC dash is zero point 0.4 times of SUT. And for cast aluminium alloys, AC dash is zero point 0.3 times of SUT. With this, you can get the value of AC dash and then you can calculate the value of SE. Clear hai?
Yes, sir. Yes, sir.
Okay, fine. Let us move forward. Next is endurance limit of a component subjected to torsional shear stress. अगर किसी कंपोनेंट में टॉर्शन हो रहा है तब आप कैसे निकालोगे इस एंड्योरेंस लिमिट की वैल्यू को? देन normally we use theory of failure, two theory of failure. According to maximum shear stress theory, this SE becomes SSE, that is endurance limit in shear, that is nothing but 0.5 times of SE. पहले आप एसी निकालोगे इस फॉर्मूले से, निकालने के बाद अगर क्वेश्चन में बोल रहा है कि फाइंड आउट द diameter of this component or length of this component by using maximum shear stress theory, then according to maximum shear stress theory, this AC becomes SSE. SSE means endurance limit stress in shear, that is 0.5 times of SE. Similarly, if you use distortion energy theory of failure, then SSE is what? SSE is endurance limit stress of the material in distortion energy theory of failure. That will be equal to 0.577 times of SE. But if any component is subjected to only axial loading, then this AC becomes AC axial, and that AC axial is equal to 0.8 times of AC. AC already you have calculated from this expression. क्या ये clear है यहाँ तक?
Yes, sir.
Okay, fine.
हाँ सर क्लियर है.
Fine. Let us move forward. Next is types of problem that we deal in fatigue design. या किस टाइप का प्रॉब्लम नॉर्मली पूछा जाता है गेट में? तो नॉर्मली फैटिक से दो टाइप का प्रॉब्लम पूछा जाता है गेट में. दैट इज, फर्स्ट वन इज when the component is subjected to completely reversed stress, and secondly when the component is subjected to fluctuating stress. Again, when the component is subjected to completely fluctuating stress, then you can design this problem for two criteria. First, अगर बोल दिया कि आपका जो मशीन मेंबर है या जो कंपोनेंट है वो 10 दिन के बाद फेल हो रहा है, then you have to use this design for finite life to solve the problem. But if the member is taking say 10,000 hours of time, 20 lakh hours of time, that means that is an example of infinite life problem. So you have to read the question 2 times, 3 times. You have to decide whether the question is of finite life case or of infinite life case. Accordingly, you will proceed. कोई doubt?
No, sir. No, sir.
Okay, fine. Let us move forward. Now, if I am solving problem on the basis of this reversed stress, then how I will solve? Now, in that case, this allowable stress will be nothing but failure stress by factor of safety. Failure stress is SE by factor of safety, and if in that same body is subjected to torsional stress, then allowable torsional stress will be how much? Will be nothing but equal to failure stress by factor of safety, and here failure stress will be SSE, failure endurance strength in shear. ठीक है, कोई डाउट? हेलो.
No, sir.
Okay, fine, fine. Next, if I am designing the problem for finite life, that means if in the question it has been told to you that find the diameter of this component which is under fatigue for 20,000 cycles or 15 days, then how to solve? Then I will use my ascent diagram to solve the problem. If you remember, when I was discussing this subject in the last semester, last semester, I solved some problems related to finite life. We used the concept of similar triangle concept. That means AEF, we took this ADB concept, then we have written that AE by AD is equal to EF by DB. DB was unknown. Then I multiplied. Then the in order to find out the value of DB, what we did, AE by AD will be equal to AD by AB into EF will be equal to DB. Likewise, we did. Did you remember?
Yes, sir.
So we
मतलब
will
पूरा प्रोसेस तो याद नहीं है, लेकिन याद है.
तो वो याद
दो
आ
ट्रायंगल
जाएगा
लेना
वो
पड़ेगा.
तो आज तो नहीं होगा, हम लोग नेक्स्ट क्लास में जब प्रॉब्लम सॉल्व करेंगे तो वो प्रोसेस याद आ जाएगा. ठीक है. तो
ओके सर, ओके.
वही यहाँ पे वही स्टेप लिखा हुआ है. तो स्टेप के पीछे मैं अभी जा नहीं रहा हूँ. हम लोग जब न्यूमेरिकल करेंगे तो हम लोग वहां पे समझेंगे कि कैसे इसको सॉल्व करेंगे. फाइन. बट आपको बस ये पता होना चाहिए कि अगर फाइनाइट लाइफ का प्रॉब्लम है, आग बंद करके उसमें आई हैव टू अप्लाई एसेंट डायग्राम. अगर फाइनाइट लाइफ का प्रॉब्लम है, देन आई हैव टू सॉल्व इन दिस मैनर. ठीक है.
ओके सर.
ओके ओके. Next and the last topic for today's class is, and in the next class we will discuss the three diagrams, that is Soderberg, Goodman, and Gerber diagram. With this, we will complete this theoretical part of fatigue, and then we will solve the problems. Fine. This is what? This is cumulative damage in fatigue. Can anyone tell me when we will apply this equation? When I will apply this equation? बताओ. मैंने बताया था जब पढ़ा रहा था डिजाइन, कब यूज करूंगा ये इक्वेशन?
याद नहीं आ रहा.
याद नहीं आ रहा है. ओके, मैं हिंट देता हूं. इफ द component is made up of different materials. फाइन. मान लो आपके पास एक गियर बॉक्स है. गियर बॉक्स के अंदर गियर का मटेरियल अलग है, शाफ्ट का मटेरियल अलग है. गियर फेल हो रहा है 10 दिन के बाद, शाफ्ट फेल हो रहा है 20 दिन के बाद. तब कैसे तुम डिजाइन करोगे प्रॉब्लम को? Then you will use this method, that is cumulative damage method, to design the problem. This equation alpha 1 by n1 plus alpha 2 by n2 plus alpha 3 by n3 and so on is equal to 1 by n. This is called minus equation. That is MINERS, minus equation. Minus equation. Fine. And it is given that if a component is subjected to completely reverse bending stress for 4 consecutive different cycles, that means जो उस कंपोनेंट का मान लो कुछ पार्ट n1 साइकिल पे फेल हो रहा है एंड द मैक्सिमम स्ट्रेस इज सिग्मा 1, कुछ पार्ट n2 साइकिल्स पे फेल हो रहा है एंड द मैक्सिमम एंड्योरेंस स्ट्रेस इज सिग्मा 2. Similarly, some part is failing at n3 cycles, or is taking time of n3 cycles, and the stress in that particular part, that is the endurance strength is nothing but sigma 3 and so on, then I can use minus equation to solve this problem. That minus equation is given by alpha 1 by n1 plus alpha 2 by n2 plus alpha 3 by n3 plus and so on is equal to 1 by n. Maximum this formula will depend upon how much element or how much small components are present in your machine and how much time is it taking. Is it clear? कोई डाउट है किसी को इसमें?
So what is the capital N denotes?
Capital N is the total life of the component. That total life will be N is equal to capital N1 plus capital N2 plus capital N3 plus capital N4 and so on.
Okay, sir. Okay, sir.
मान लो आपके पास एक शाफ्ट है, वो कंपोजिट शाफ्ट है। पहला वो शाफ्ट सीरीज में जो लगा हुआ है, पहले शाफ्ट का डायमीटर 10 mm, दूसरे शाफ्ट का डायमीटर 20 mm, तीसरे शाफ्ट का डायमीटर 30 mm। पहला शाफ्ट मान लो बना हुआ है स्टील से, दूसरा शाफ्ट बना हुआ है मान लो कॉपर से, तीसरा शाफ्ट किसी और मटेरियल से बना हुआ है। तो जरूरी तो नहीं है कि तीनों शाफ्ट एक ही टाइम पे फेल करेगा। हो सकता है कि पहला वाला जो शाफ्ट है वो फेल करे मान लो 3 घंटे में, दूसरा वाला शाफ्ट फेल करे 10 घंटे में, तीसरा वाला शाफ्ट फेल करे 15 घंटे में। दैट मीन्स here the failure of the mechanical of the machine is not certain. In that case, we use this minus equation. And this N1, N2, N3, N4 is what? Capital N1, N2, N3, N4 is the total life of that particular individual component before fatigue failure.
Okay, sir. Okay, sir.
ठीक है? ओके, बाकी लोगों को कोई डाउट है किसी को कुछ?
No, sir.
नहीं सर, ठीक है।
Okay. So with this, I am ending today's lecture. In the next class, we are left with 3 diagrams. That is Soderberg diagram, Goodman diagram, Gerber diagram, their equations, and after that we will solve the problems, previous year's gate problems, which they have asked in previous 4 to 5 years. ठीक है? Hello.
हाँ सर, ठीक है।
Okay. So before leaving, what you do is that if you have not given your attendance, write your attendance in the chat box and please fill up this form which DKD sir has given for attendance. If you are
Sir,
done,
DKT sir has given 5 different forms. Which
uh,
one we have to fill up?
wait. Let me check. पांचों एक ही
Okay,
फॉर्म
sir.
है कि
Okay,
अलग
sir.
अलग फॉर्म है? Wait, रुको थोड़ा सा. Let me check
Okay.
the single form. Name, student, stream, section, name, student, stream, section. No, it is same only. The form is same. You can click on any one
सर, आप
link.
थोड़ा लिंक भेज दीजिए ना चैट
Okay, sir.
बॉक्स में।
Okay, sir.
Link is already given in the chat box. Open the chat box. Chat box खोलो, उसमें already सर ने दिया है link, DKD सर ने.
नहीं कर रहा है।
नहीं शो कर रहा है, ठीक है, मैं फिर से उसको रिटाइप कर देता हूँ लिंक, एक सेकेंड. Copy the link address and paste. ये लो, मैंने दे दिया.
ओके सर।
Once you are done with these things, then you can leave the meeting. Thank you.